I'm covering Trig Unit 2, Day 2, and this is inverse trig functions within restricted range, or what we call principal values. So I'm going to define that, and we're going to find principal values. The good news is today, instead of getting 6 answers for every question, you're only going to get one. It's just which one is the right answer. So the values of inverse trig functions can correspond to an infinite number of angles, and we talked about that the first day. You can find your base angles and then add 360 and subtract 360 an infinite number of times, and you can get an infinite number of answers. So we looked at finding answers between 0 and 360 or 0 and 2 pi, and 0 or negative 360 and 720 or negative 2 pi to 4 pi. Today we're going to find one answer. It's going to be between 0 and 360 or 0 and 2 pi. But as you know, we've got two quadrants that are positive and two quadrants that are negative for each trig function. So it's which one of those are we going to pick. So first definition, smallest absolute value of an inverse trig function is called the principal value of the function. So notice the absolute value. So and you have to think of your clockwise angles when you think of this, else it's a little confusing. So for instance, if you have an angle of 315, that corresponds to a negative 45 degrees, and absolute value is going to be 45 degrees. So that's why maybe sometimes the definition and what the principal value is may not make sense, but it's because they use those negative angles in quadrant 4. So here's an example. Square root of 2 over 2. This has a reference angle of 45 degrees. It's positive. Sine is positive in quadrants 1 and 2. So we would have two angles. The first day we found two angles, and the reference angle of 45 in quadrant 1 is 45 degrees. The reference angle in quadrant 2 is going to be 180 minus 45, or 135 degrees. So those are our two base or primary angles. Given the definition of the absolute value, the smallest absolute value angle here would be our 45 degree angle, and that's what's going to be our principal value. What about negative square root of 2? So our negative quadrants are here and here. And as I said, if I get the 45 degree reference angle in quadrant 3, we're going to add 180 and 45 to get 225. Even as a negative angle, it's going to be a negative 135. So this is the negative angle is smaller, so we might want to look at that. But look at this one. This is 315 degrees, but in negative terms, it's a negative 45. Of these four potential angles, which would have the smallest absolute value? It would be this one. Negative 45, absolute value is 45. It's the smallest absolute value angle of the four. And so negative 45 or 315 degrees would be our principal value for inverse sine of negative square root of 2 over 2. And you may be wondering, why do we want something like a principal value? Well, if you would notice, if you put an inverse function into your calculator, how many answers do you get back? You get one back. The answer you get back is your principal value. So if we need to understand that concept, and then tomorrow we're actually going to be using the calculator, and you hopefully will understand that when you put in a negative sign, a sign of a negative ratio, the angle you get back is going to be an angle from quadrant 4. So you have given the sign of the ratio, positive or negative, and the actual trig ratio. Because of where they're positive and negative, you're going to get positive results, or positive ratio results from one quadrant and negative ratio results from another quadrant. For sine and cosine, they're going to be, the quadrants that you get things out of. Positives come out of 1 and negative come out of 4. So that means that your principal values for sine and, sorry, not cosine, cosecant, sine and cosecant are going to be in the range negative 90 to positive 90, which is also negative 2 pi to positive 2 pi. I think this should actually be there. That shouldn't be there. I think the equal sign does not belong there. All right. This is true since the values of sine are the same in quadrant 1 and 2 and 3 and 4. So these are the smallest. These two quadrants are going to give you the smallest absolute value, and we don't need to duplicate the answer. We only need to get the answer once. The values in quadrant 1 and 4 cover the range of possible values for sine, inverse sine, while the absolute values of the angles are the smallest. All right, so let's look at the other functions. Principal value ranges for other trig functions. So for cosine and secant, they're going to go from 0 to 180. So that means they're going to be in quadrant 1 and quadrant 2, because these are going to give you the smallest absolute value. Smallest absolute value of positive ratios come out of this quadrant. The smallest absolute value negative ratios come out of quadrant 2. So in cosine, your other positive quadrant is here, and essentially these would be like the same, but since this is already a positive, the positive angle or counterclockwise angle works in quadrant 1, the principal value is going to come out of quadrant 1. In quadrant 3, it's also negative for cosine and secant, but because this quadrant 2 has a smaller absolute value, the angles come out of quadrant 2. For tangent, the principal values are as follows. Notice this is the same as sine and cosecant. So positive here and negative here, because negative for tangent is here and here, and these are smaller absolute values. Why isn't cotangent listed with tangent? Because actually cotangent and tangent have different ranges. Cotangent has the same range as cosecant and secant. So you're going to get positive here and negative here. And you might ask why. It has to do with where cotangent and tangent are undefined. So tangent is equal to opposite over adjacent. So when A is 0, and that's going to be, where's A 0? It's going to be on your y-axis. So you can't really have a range that crosses that y-axis because you're going to end up with an undefined value here. So for tangent. So that's why the range for tangent goes from negative 90 to positive 90, because it avoids crossing over that undefined zone. In cotangent, it's adjacent over opposite. So let me erase this. So where is it undefined? It's undefined when the opposite is 0. Where's the opposite 0? The opposite is 0 on your y-axis. So we don't want to go from negative 90 to 90 because that's going to take us through this undefined point. That's why it goes instead from 0 to 180, so then we don't have to cross the x-axis. So hopefully that's a little bit of an understanding. And this graph kind of explains what I just told you. If you look at the graph of tangent, basically, whenever you're kind of near, so here is negative 90, here's positive 90, you have this asymptote, and we talked about those before, that where this graph would never cross that line of negative 90 or positive 90. For the cotangent, we have our asymptotes here at, it's kind of hard to see, but they're going to be at, am I doing that right? Do I have these right? Let's see, positive 90. Yes. And so these are going to be at 0 and pi. So 0, I'm sorry, I couldn't see these very well. Pi, these are where the asymptotes exist for cotangent. And so that's why you have to have the ranges different. So if you can kind of remember, tangent goes with sine, cosecant, and cotangent goes with cosine. So if anything, because it's a cotangent, maybe it'll help you remember cotangent and cosecant go together. All right, so let's look at some examples. Here's a summary principal value map. So notice all the positive ones come out of quadrant 1. So if you can remember, quadrant 1 has all your positive principal values. Quadrant 4 has sine, cosecant, and tan, and cosine, secant, and cotangent come out of 3. And you never, ever, ever have a principal value coming out of quadrant 3. So if you get one, if you have your answer that's in quadrant 3, you've done something wrong. All right, find the principal value or restricted range. I'm not sure, the terminology changed a little bit, so it may be worded this way or this way. Inverse tangent of negative square root of 3 over 3. All right, so tangent is opposite over adjacent. Remember, this is one that we have to derationalize, so opposite over adjacent, the original is going to be a negative 1 over square root of 3. If we draw this, opposite is 1, adjacent square root of 3, that gives me a 30-degree reference angle. It's negative, so since it's negative, principal value, its tangent, we're going to take it out of quadrant 4. So the angle is going to be 360 minus 30. Or you could even tell me negative 30. So 360 minus 30 is 330. Either of these answers would be okay if you want to just leave it as the negative angle. Example, find principal value for arc cotangent of negative 1. Okay, cotangent is opposite or adjacent over opposite. So this is going to give us adjacent over opposite is going to be equal to negative 1 over 1. That's going to give us a 45-degree triangle. So 45-degree reference angle, cotangent is negative. So cotangent we take out of the negative ratio out of quadrant 2. 45 degrees. So this is going to be 180 minus 45, or 135 degrees. So really the only thing you need to remember is which of the 4 quadrants do I get the angle from. We're not doing anything different than we have been doing. It's just we're going to have fewer answers. You just have to pick the right one. Find the principal value for tangent of 0. Tangent is opposite over adjacent, 0 over 1. So where's opposite 0? Well, whenever the y-coordinate is 0, then your opposite will be 0. So we know it's here and here, our quadrantals. But remember, our range for tangent is here. So the only answer that we get is going to be in this range, which means it's going to be this one, or 0 degrees. So that would be our answer. All right, I would like you to find the principal value for this. And you should make sure you can do it. It's a little hard to see. It's arc cosecant, in case you can't read that. Cosecant of 2 square root of 3 over 3. You should check your answer in class. And other than that, you will be doing the worksheet and bring any questions to class with you.